Okay, thank you. I was really inspired by a book called Why, How, What from Simon Sinek. And he basically argues that in every project, in every process, we should really start with the why. We should really start with the kind of problem statement, the problems we are going to solve. And after that, we can look further into how to solve it. So that's also the way I structured this presentation for today. I looked at the current building industry and some problems that are really prominent there. It was kind of easy because the current building industry had lots of problems, but I only talk about 3 problems these days. First is inefficiency. This graph shows the gross added value per man hour. It's basically the productivity of the average industries, that's the dotted white line. And you see that in the last half century it's almost tripled on average. And the yellow line, it shows the productivity in building industry. You see that today we are more or less on the same level as 50 years ago. So this was really shocking to me. Another graph that was shocking for me was the pollution. We all know the numbers about energy consumption of buildings or the CO2 emission, but this really shows the amount of waste in landfills of all different industries we have on this planet. You see that 50% is a result of the building industry. And the third problem is in the inflexibility. In Holland we even call real estate vastgoed, which means something like fixed goods. You see that the total amount of vacancy in the Netherlands is 72 million square meters. So it's way more than the 11 million square meters of vacant offices you often hear people talking about. You see that this is almost 4 times the total amount of production in building industry in 4 years. So with these ideas or these problems in mind, I came up with a kind of a building system, which is basically Lego for buildings. So similar to Lego, probably you all know the thing kids play with. It consists of smaller elements you can easily carry around, and you can create unique assemblies with. And similar to Lego, you can easily also take everything apart again and reuse it in a unique assembly again. Like Tilman also already said, we tested this in the PD lab, the product development lab, the white shiny pavilion outside in front of the west entrance. And in my company we are currently applying this indoors. So currently only indoors in a commercial way. So for example, to transform a vacant retail space into micro-dwellings, or to upgrade a very old, outdated office environment into a very new, flexible one. And with this system, there are basically 3 characteristics that we use in order to tackle these problems. So inefficiency we tackle, or we try to tackle, to use a completely design-build process. I will talk about that later on. We try to eliminate pollution by using a naturally circular process and create products that are not only circular, but also mainly bio-based. And the inflexibility is addressed using mass customization. So I'll explain about these 3 in more detail. I'm really convinced that in order to make an impact, we need to integrate not only the design, but also the engineering and the production. That's why I call my company the new makers. We are not only architects, not only engineers, but we are makers as well. And we can integrate all this feedback we have in the making process again into the design and the engineering phase. So this is the heart of our company. It is 2 CNC milling machines, because we produce everything 100% digitally. So we send a file to these machines, and we have total control over the whole process. You see that this is, for example, such a model. We have all the knowledge of every square millimeter and also all the influence of every square millimeter of the design. And for example, what you see that in such a very well integrated process, we are able to eliminate the failure costs. You see that in the current building industry, the failure costs are on average 12%. So that's really huge compared to other production industries. And we try to bring it down by using a full digitally design, engineering and production process. So this is basically the file in the file to factory process. So you also heard the terminology, the new master builder. You saw that really at the beginning of the Renaissance. You had these master builders who are building our cathedrals. And these were people who are controlling the whole process from the first sketch. And later on, after 10 years, they were walking around on the building site and telling the masonries how to cut their stones. And I think with these new digital tools we have, both in the design process but also in the production process, we can try to bring this craftsmanship back into architecture and have, as architects, also a new role. The terminology naturally circular means that we not only look at the circularity of certain processes, but we also try to use as much natural materials as possible. So for example, if you look at, this is a particle wall segment, you see that construction is fully wood-based and that the insulation is made from upcycled jeans. This is acoustic insulation. And you also see that in the production process, we are able to completely integrate all the detailing. So these CNC milling machines, they have an accuracy of 0.1 millimeters, which makes it possible to create new smart connections where everything can be fit together, but also everything can be easily taken apart again. So it's only dry connections, also called friction fit. And not only such a building block can be taken apart, but also all assemblies. This was a competition called Home Away from Home. And we won this competition, I think, mainly because we were able to create extreme flexibility for the influx of asylum seekers. So for example, if there was a new influx with a new cultural background or a new family size, we could easily rearrange this. Just using an hexagonal wrench, we could take out the building again and assemble it in a new, unique way. And of course, circularity goes further than just the product. So for example, this is our production process. And you see that over here, that we use all the dust in our production in order to heat our workshop in the winter. And also the leftover pieces. And it's in Dutch, but restmateriaal means leftover pieces. It's being reused again in the creation of new sheets. And just like Tilman explains, circularity actually only starts when the project is delivered, when it is produced, because it's about the total life cycle of a product. So we try to go to a full service model by not only offering a product, but also, for example, offering maintenance and, for example, even cleaning in the buildings. We do this together with other companies. The third characteristic I wanted to talk about is mass customization. You will probably hear this terminology later on as well. People also say that the first industrial revolution was all about mass production, so producing in large quantities, so products could be made more affordable for the average people. And you see that today, with digital technologies, we can produce customized products, but still with the efficiency of the first industrial revolution. I think we should also use this in a balanced way. So not only see this mass customization as a goal, but we as a company, we produce products standardized when it is possible, and only customize them wherever there can be an added value, wherever the customization is really required. So for example, this is a project we will be soon producing. It is a transformation of a vacant retail space into micro-dwellings. So all the gray area that's actually an existing situation. You see that some of these assemblies, like the brown ones, they are completely separate from the existing situation. So we made these from standardized elements, and we can reuse them very easily, take them apart and reuse them later on in another situation. And some elements, like for example such a wall here, it is completely connected to the existing situation. So a wall like that is based on a 3D scan of the existing building, and it's completely customized. So we try in this way to balance this customization and the standardization aspect. We also are developing an interface in order to connect our building system with. It can run in a browser very easily, even on a tablet. This is a sneak preview of that. You see that by combining such a digital process with the internet, so with a platform, you can also change the design, the engineering, and the production process. So all the actors, for example, are completely changing. So in this way, the end user, because it's very easy to do this, the end user can suddenly have huge influence on the design. And also, for example, here you see a database. This database can also be developed with other companies. So now we as the new makers, we develop the first few items, just like Apple developed the first few items of the App Store. But of course it can be open to others as well in the future. And also the production can be open. Because if, for example, this setting will be produced in the USA, then of course it would be silly to produce it over here and ship the products to there. We can easily ship the code to there, and then it will be produced locally. So that was the end of this small talk.